Hello there! We are Group Kale. My name is Carson Martabano, and who wants to introduce himself
My
now?
name is Korey Wilson.
He is Korey Wilson.
I'm Luke. Iannuccilli. You probably won't be able to pronounce my last name, but that's fine.
Unpronounceable Luke.
And I'm Gino Deserio.
There we go. And he's very deserious. No, but in all seriousness, today we are here to present the physics properties of density and volume. Ooh. So, this experiment is going to entail a golf ball, a cat ball with a bell in it that's kind of wet, and an egg. Unfortunately, it is expired, so that's why we're experimenting with it. So, here we have a measuring cup filled up with 3/4 cups of water. We're going to start off with this tennis ball, which is hollow on the inside with a cat toy in it. Now, water has a density of 1 gram per cubic centimeter. So, if this floats, that means that it is less dense than water. Let's watch. Oh my god, it floats! It floats! It floats! Yay! Next up is the unlucky 8-ball. Woo! It's unlucky, and I can tell you from personal experience that this is denser than water. Because when I was out with my girlfriend playing mini golf, I lost the game because this went in the water, and it ruined the entire date. So, same water as was in the previous experiment. Gino, if you will drop it in the water and whatnot, you know, the experiment, etc.
Ready?
Yeah, no, I'm
Ready?
I'm ready. I think they're waiting. Anticipation is building!
Ooh.
Hey, man, we don't need a splash. We got an expensive computer there. Full Sail will not refund you on that. So as you can clearly see, it sank to the bottom. Now, the cool thing about this is we can measure how much water was displaced. Now, 3/4 of a cup is where it was. Now you can see that 3/4 of a cup was at 175 milliliters. It's about the same amount of water. So, the volume is now moved up to right under 200 milliliters. You could basically extrapolate from this that the addition of the rising water means that the volume of that 8-ball golf ball is circa 50 milliliters, although if I had to guess, it would be closer to 40 milliliters based on how far away it is from the line. Now hit the pause button! Hit the record button! Oh, wait, no, that happened. So, the next thing we're going to show you is going to be a little more long-winded, so I ask that you bear with me. This is regular water, correct? Yes? Actually, you have no idea. I could be lying. It might be anthrax. Who knows? Be scared. Anyway, if I put it in this water, you will see the egg sinks. And also you will see that it has more volume than that golf ball because it went from the 175 milliliters to 200 milliliters. Now, question. How could we change the density of the water to make this egg float? Not float on top, but float in... Yes, wait. No, I'm getting to that. You're ruining it! How could we make the... You know what? Screw it. You put salt in water and it changes the density of the water, which will later allow the egg to float. But we're not trying to get her to float on top. We want it to stay submerged in the water. So, now we shall do that. So, now that we've added salt into the water and stirred it vigorously, now, as you remember, the egg sank previously. Having mixed in a bunch of salt into the water, making it into salt water, let's see what happens. What? Oh my gosh, no way! It's like not sinking and stuff, it's totally floating. We're geniuses! Physics! So to reiterate our point, water has a density of, bless you, Korey, bless you, Korey. It has an exact density of, bless you, Korey. Now, it has an exact density of 1 gram per cubic centimeter. So, what that means for humans is, basically, if you have a density less than that, then you'll float. Which is why, since we have hollow parts, you know, the parts where air goes through, that's why we float and don't sink, just like this tennis ball. Now, let's say, oh, this is still the salt water. I don't know if this will work, don't demote us, but now let's say a rock, like if you had a pet rock, if you took it swimming, it would probably drown. And that would be very sad. So, density and floating in water as well as displacement is all related to if you are more dense or less dense than water. If you're less, you float. If you're more, you sink. And if you can equalize it out with salt, which was pretty cool, then you'll just kind of stay where you sit. which is kind of a problem because humans can't breathe, then you'll drown and die, and I'll have to attend another funeral. I don't know if I'll eulogize you, I'm not sure, don't know if I know you well enough. I'll hug your grandparents and tell them that, you know, you're a great person and you loved them very much. But aside from that, there's not much to be said about density, and as far as volume, it's pretty simple. You know, you take everything out, and it's at, and this one is a lot bigger. It's right now at 350 milliliters. Drop a golf ball in, and it's at 400. So that's how you can easily calculate volume if you're not into math. Cool. Party tricks. It's a cat! And now it's going over there. I want to talk about why any of this matters in our degree. Now, thank you all for watching. Now get ready for some bonus physics. Newton's third law states that every action has an equal and opposite reaction. Now Luke doesn't know it, but he's about to get smack-cammed for physics.
Yeah.
Let's watch.
Alright, Luke's outside right now. He's got the egg. And we're gonna get him. We're gonna try.
Smack-cam! What the hell? Now you can clearly see that every reaction has an equal and opposite reaction, including on my face. See, it's original. This is really funny. This original. No. He don't need a towel.
Alright, so I just got egged, but I'm assuming if it was the same egg that we worked with, it was expired,
Yeah, it was.
rotten.
So basically, every reaction has an equal and opposite reaction. The egg reacted to the wall that it hit, which was Luke's head, and exploded because of the force of his head when it hit it. So that's bonus physics for you. Thanks for watching again. He's not going to be happy. We're going to go now. Bye.